Welcome back, everyone. In the last part of this section, we are going to talk about solving equations where there's an inverse trig function. So the plan is we'll start off always by isolating our inverse trig function, rewriting it so that that inverse trig function is just by itself on one side of the equation. And then think about that inverse trig function and its range, because it's possible, just like any equation, that there might be no solutions. So for example, if we had moved everything over and we had sine inverse of x equals to pi, we would take a minute to think to ourselves, what is the range of sine inverse? What are the output values it gives? And remember that for sine, we'd restricted the domain from negative pi over 2 to pi over 2, which means for sine inverse, its range would be from negative pi over 2 to pi over 2. Now, since pi is not inside that interval from negative pi over 2 to pi over 2, then that means this equation, sine inverse of x equals pi, would have no solution. So in which case, if that were your equation, you could stop right there and say no solutions. Now, if you know that there will be solutions, then the next move is to just take that inverse trig equation and rewrite it as a trig equation. So instead of having sine inverse, rewrite it involving sine. Remember that for inverses, we switch the inputs and the outputs, so that instead of having x as the input for sine inverse, x would be the output for sine. Instead of having a as the output for sine inverse, you would have a as the input for sine. And now once you've done that, you've got something where you'll have sine of some number, or tangent of some number, or cosine of some number, and then you can go right ahead and evaluate that. If it's a nice angle, well, then you can evaluate it directly using your special triangles. If it's not, then you can use your calculator to give an approximate value. There is one little last twist, which is maybe after you've isolated your trig function, it's not just a trig function of x. Maybe it's an inverse trig function of something involving x. So maybe you have something like sine inverse of 3x equals to 1. And if you were thinking of solving that, the plan would be to simplify it a little bit by replacing what's inside that inverse trig function with u, doing a little substitution, so that instead of having sine inverse of 3x, we would have sine inverse of u, and then we could solve for what u is. And then don't forget that once you've solved for u, you still need to tell me what your answer is in terms of x, so go backwards and use that to solve for x. And we'll see a couple of examples of that as we go ahead. So let's start with the first example. We want the exact solution to 18 arctan of x minus 6 pi equals 0. So first thing that I'm going to do is just rewrite it, moving everybody from one side to the other, except for the inverse function. Instead of writing arctan of x, I'm writing tangent inverse of x, because of course that's the same thing. I move the 6 pi to the other side. I divide both sides of the equation by 18. And so now I've got tangent inverse of x is 6 pi over 18. And if you were to simplify that fraction, 6 goes into itself once and goes into 18 3 times. So we've got tangent inverse of x is equal to pi over 3. And if we're just thinking for a minute about tangent, when we restricted its domain, it was restricted to negative pi over 2 to pi over 2, quadrants 1 and 4. And the angle that we're talking about, pi over 3, well, that is in quadrant 1, so it is in the range of tangent inverse, which means we will have a solution to this equation. And so next thing that we'll do is we'll just rewrite it as a trigonometric equation rather than an inverse trig equation. Instead of tangent inverse, we'll have tangent, and we'll switch the inputs and outputs. Instead of pi over 3 being the output for tangent inverse, pi over 3 will be the input for tangent. Instead of x being the input for tangent inverse, x will be the output for tangent. So now we have tangent of pi over 3 is equal to x. So only thing left for us to do now is, since we want to know what is x, and x was tangent of pi over 3, well, now we just need to evaluate tangent of pi over 3. And this is where I'll quickly doodle down my special triangle with 30, 60, and 90 degrees. Pi over 6, 30 degrees, opposite that, the side length is 1. Pi over 3, 60 degrees, opposite that, the side length is root 3. And 90 degrees, opposite that, the side length is 2. So we're looking for tangent of pi over 3, and tangent of pi over 3 should be opposite over adjacent. So that should be root 3 over 1, or just root 3. So then we could say that our solution set just contains root 3. There we go. So this is an equation that we have where there is exactly one solution. So that equation, 18 tangent inverse minus 6 pi equals 0, we've solved it. We found that there's one solution and that the solution is root 3. All right, let's do another one. Let's start off with, again, first we'll isolate that inverse trig function. So I'll move the pi to the other side. Minus 3 sine inverse of 2x equals, moving the pi to the other side leaves me with pi. Lovely. I'll divide everybody by negative 3. That's sine inverse of 2x equals negative pi over 3. And just to take a minute to think about, is pi over 3 a value, is negative pi over 3 something in the range of sine inverse? And so I need to remind myself again, when we restricted the domain for sine, we've restricted it to quadrant 1 and quadrant 4, between negative pi over 2 and pi over 2. And negative pi over 3, that is in quadrant 4. So yes, this is something that is part of the range of sine inverse. Negative pi over 3 is something that's in the range, which means that we will have a solution to this equation. If this angle had not been in quadrant 1 or quadrant 4, if let's say this had been something like 2 pi or 5 pi, something that wasn't in that interval from negative pi over 2 to pi over 2, then our equation would have had no solutions. But so now that we know that there is a solution, we'll get ready to solve. And so here I'm going to, before I do that, do a little substitution, because it's not just sine inverse of x, it's sine inverse of 2x. So I'll just make a little note to myself that I'm going to replace 2x with u. So we have sine inverse of u is equal to pi over 3. And now that we have sine inverse of u is equal to pi over 3, we're going to rewrite that as a trigonometric equation. Because if sine inverse of u is pi over 3, then switching the inputs and outputs, sine of pi over 3 should be equal to u. And this is where we'll go back and, again, draw our special triangle. For our 30, 60, 90 triangle, 30 degrees, 60 degrees, and 90 degrees. We have for sine of pi over 3, that should be opposite over hypotenuse. That should be root 3 over 2. So that's telling us then that u, which is sine of pi over 3, should be root 3 over 2. Now, that doesn't solve all of our problems, of course, because that tells us what u is, but we didn't want to know what u is. We wanted to know what is x. And so this is where we need to remind ourselves that we said that u is equal to 2x. So, since u is equal to root 3 over 2, that means that 2x is equal to root 3 over 2, which if we were to solve for x, dividing both sides by 2, we would have root 3 over 4 is equal to x. So our solution then would just be that single solution of root 3 over 4. So our solution set, just the single value, root 3 over 4. Okay, let's do a couple more. We have negative 4 cos inverse of x equals 7 pi. And I will rewrite this just with cos inverse by itself. Cos inverse of x is equal to negative 7 pi over 4. Okay, good. Now, starting to think about my range for cosine inverse. Remember that for cosine inverse, we had cosine restricted to quadrants 1 and quadrant 2. The restricted domain from cosine was between 0 and pi, so the range for cosine inverse will be between 0 and pi. So we have a problem here. This is not inside that interval from 0 to pi. And so since it's not in the range of cosine inverse, remember cosine inverse will only give you output values in quadrant 1 and quadrant 2. That's not a number that's in quadrant 1 or quadrant 2, so too bad for us. There is no solution to this equation. So I could say that since negative 7 pi over 4 is not in the range of cosine inverse, there is no solution. And then that's that. There's nothing further to do. Because, of course, if you wanted a solution to the equation cos inverse x equals whatever, that whatever would have to be something in the range of cosine inverse. Since negative 7 pi over 4 is not in the range of cos inverse, then there's no x value as an input that will give you negative 7 pi over 4 as an output. And then that's kind of that. All right, one last. We have a little bit more complicated looking equation, but again, no big deal. We'll use a substitution to help make our lives a little bit easier. First, I'll rewrite things with the pi moved to the other side. And then dividing by 6. And if we're thinking about sine, we know that the domain that we restricted sine to was in quadrants 1 and 4 between negative pi over 2 and pi over 2. And the angle that we're looking for, pi over 6, that is in quadrant 1, so that is in our range for sine inverse. So the equation will have a solution. Notice again, this is one where it's not just sine inverse of x, it's sine inverse of a function of x. So this is where I'll maybe do a little bit of a substitution. I'll replace x minus 3 over 2 with u. So that means I would now have, instead of sine inverse of x minus 3 over 2, I would have sine inverse of u equaling pi over 6. So we have sine inverse of u equals pi over 6. And to rewrite that as a trig equation, we'll use sine, and we'll switch the inputs and the outputs. Pi over 6 is the input, and u is the output. And if you're using your special triangles, 30, 60, and 90, for sine of pi over 6, that would be opposite over hypotenuse. That would be a half. So we have that sine of pi over 6 is a half. So in other words, a half is equal to u. And then don't forget, you've solved for u, which is wonderful, but you were actually looking to solve for x. So we'll use the fact that u is x minus 3 over 2. So instead of u equaling to a half, we'll have x minus 3 over 2 equaling a half. Multiply both sides of the equation by 2. I'll have 1 equals to x minus 3. Bring the 3 over to the other side. I'll have x equals to 4. And then there we go. I've done my solving. I can say, therefore, my solution set is the single value 4. That this would be the one number that we could put in for x that would make the left side and the right side of the equation equal to each other. So the solution to this equation, 6 sine inverse of x minus 3 over 2 minus pi equals 0. So for this equation that we were given, the solution is x must be equal to 4. All right, good work, everyone. Thank you for following along for what was a fairly long lecture. When we meet again in section 8.2, we'll talk a little bit more about composition of trig functions with inverses, except we'll be mixing things up. Instead of composing sine with sine inverse, we'll compose, for example, sine with tangent inverse, and we'll have to think about what would happen there. So lots of interesting things to talk about, and I will see you all very shortly.